4.3 reciprocal graphs, reciprocal function. What is reciprocal? Not important. But what is happening because of reciprocal? What you can see, you will see that if there are two variables, let's say x and another one is y, you will see when x is getting bigger, y is getting smaller. If you when x is getting bigger, the y is getting smaller. And if x is getting smaller, y is getting bigger. That's the understanding of the reciprocal. For example, x is the petrol price of petrol price. When the petrol price or the fuel price increasing, tell me something about decreasing. Um, when the fuel price is increasing, the car prices is going down. At present, fuel price is let's say petrol price 130, £1.30 per liter, and the car cost is 12,000. What will happen? This is become £2.50. This car prices will going down. Usually, it will become 8,000. What will happen if it is £10? All the car prices will go down to around 3,000. Right? Nobody wants to drive. Everybody is looking for public transport to try to walk or try to find a bicycle. And what will happen around £50? This is all 1,200. So this is the feature you want to see that. And same way, when the prices is decreasing, this value price is decreasing 10, this one increasing. When it's 2.5, 8,000. 130, 12,000. In other way, when it's 130 to 230, it will decrease. This is increase, this is decrease. Increase, decrease, increase, decrease. Right? When this is decrease, this is increasing. Become to 2,000. I'll increase another £7.50. Now £2.50. It has come to 8,000. So likewise, one is increasing, the other is decreasing. So it is something like this. This is the idea behind it, the reciprocal. Now, y equal 1 over x. I will increase the x price. Then what will happen to the y? If this is x value, this is y value. Right? When x equal 1, we'll do the calculation. Y equal 1 over x. 1 x equal 2. Then this is 1 over 2.5. When x equal 10, y equal 1 over x, y equal 10. 0.01. X equal 1000. X is increasing. Y is become 1 over 1000, which is 0.001. 0.001. X equal 10,000. Then Y equal 1 over 10,000. This is 0.0001. We'll put this one into the graph now. It is this kind of graph. X equal half, X equal 2. When X equal 2, Y equal half. This is half. When X equal 1000, 10. Y equal 0.01, 0.1, not 0.1, 0.1. And when X equal 1000, very far. This is 0.001, 0.001. Then 10,000. X equal 10,000. This is 0.00001. Now, what will happen? X value is getting smaller now. Now, X value is 0.01. X value is 0.1. Then Y over, let me erase this one now, I can't keep it. Y over 1x. Y over 1 over 0.1 become 10. This is 10. Right. Then Y over, I'll take 0.01. This is become 1 over 0.01, 100. Then 0.001. Now I am making x smaller. Y equal 1.001, which is this is 100, and 0.01, this is 1000. What I am doing here now, I'll delete this one. I put 2, which is 0.5. Then I put 2, 10. This is 0.1. Then I put I think 1000, 100, 0.01. I am rewriting the previous one, 1000, 0.001. So this is what we did here now for this. Now I am reducing it. It means I am making x value smaller. When I am making x value smaller, what will happen? The y value become bigger. Okay. X is 0.1 now, somewhere here. Y is 10 and X is 0.01. X is 0.01. Then the value is going to be 100 and X going to be 0.001. I can't write here 0.001. Then this value become 1000. Right. I'll take another value, X value. 0.000000001. This will become 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm not trying to read it. Right. Somewhere here. It is very closer to the curve. Very closer to the curve. Very far. 1, no, 0, 0, 0. Now I'll put another X value. 0.0000000000000. I will write this one up to your home, and then you can see 1 at the last one. Now when I divide 1 this number, what will happen? It's going to be a very bigger number. So still I have to mark. But when we write a function like that, there is a restriction. Y equal 1 no x. But they will say x is not equal to 0. Why x is not equal to 0? Because whatever the values you put, you will never ever touch x equals 0. X equals 0 line. You can see that when x value getting bigger and bigger and bigger, you will get bigger and bigger y values. But it will never reach x equal 0 line. So can you see that now we are when the x value is reducing, what will happen? 10,000, 100, 10, then 0.1, 0.01, 0.11, and this number I am getting to 0. Right? I am walking towards the 0. But I will never ever reach 0. Why I can't reach this 0? X equals 0 line. Because this is a asymptotic. Asymptotes. Again, just to revise again, you have come x value is coming towards the x equals 0 line, but it will never ever reach uh, x equals 0 line. It will only reach at infinity. So if you find a line like this line called asymptotics. That's why when we write a reciprocal function like this y equal 1 over x, we'll tell that x is not equal to 0 because why? You you will never ever reach this x equal 0 line. You will never ever reach x equal 0 line. You can see that from the function. Now y equal 1 over x. Okay, so they will tell don't take x equals 0. Okay, you take x equals 0. What is 1 over 0? 1 over 0 is infinity. I am going a little bit further, not undefined, but I will tell it is infinity. It means only you can reach this x equals 0 line at infinity. Hence, this graph will never reach x equal 0 line, which is asymptotic. Actually, I didn't draw the other part of y equal 1 over x is still the same. Right? It will never reach from this side. It will never reach if you go this way. Uh, you will never ever reach x equal 0 line from this side as well. Then this x equals 0 line is asymptotic. But I don't want to confuse you. But can I do a cross multiply this one? I can write y equal 1 over x equal 1 over y. Now we know x equals 0 is asymptotic, which is y-axis. X equals 0 line mean y-axis. Y-axis is asymptotic. Okay, it is on like this. So then it is called vertical as well. This is vertical. If you draw this one horizontal. So y-axis or x equals 0 line will call vertical asymptotic. Asymptotes. Now I will write like this. Y equal 1 over x, I cross multiply and I can write x over 1 over y. And when you look at that, the same thing happened to x-axis as well. Y is getting now when is getting this one is getting smaller and smaller, what will happen? Y is getting bigger and bigger. In other way, right? When x is getting bigger and bigger, what will happen? X is getting bigger and bigger, what will happen? Y is getting smaller and smaller. Well, it means Y also were asymptotic because we can't tell Y equals 0. If I take Y equals 0, 1 over 0 is infinity. In that case, it will confuse you, but still I try to explain this one. Y also asymptotic because you can't take y equals 0. If y equals 0, we can see from the function, even you can see that when x equal 1000, 10,000, I am increasing this way, and I will write x value instead of this one. I am writing a big x value instead of this is decimal. I will put all the 0, 1 0 0 0 0 0 0 up to your house. Then what will happen? When you put 1 over that number, it will become very, very small value. And now you can see that when y is getting smaller and smaller, sorry, yes, y is getting y is getting to 0. X value is getting bigger and bigger. But this, now we are coming this y value 1000, 100 likewise, but you will never ever come to this y equal, this x-axis mean y equal 0 line. Hence y equals 0 is a asymptotic. Y, oh, y, okay, y mean x-axis, x-axis, so y equals 0 line. Y equals 0 mean x-axis is a asymptotic. But since it is horizontal, it is a horizontal. It is a horizontal asymptotic. Now let's discuss another function. I will write 1 over 1 x plus 1. Then they will tell, okay, x minus 1. They will tell that x can't be 1. Then what is the asymptotic? So x equal 1 is x equal 1 is a asymptotic. Why? Because when I sub here y, what will happen? X can't be sorry, this is x can't be 1. Hence, x1 is a asymptotic. What will happen? If we put x equal 1, 1 minus 1 is 1 over 0 is going to be infinity. So the machine will break. You can't process this number. Hence, x equal 1 is asymptotic. In other way, you will never ever reach, right? This is y-axis, this is x-axis, and this is x equal 1 line. You will never ever reach x equal 1. So this is the graph is going to be this kind of graph. It will meet at the infinity. So I can't draw like this. Then it's wrong. I want to go and I want to write as infinity. Now this is also wrong. So this has to be, I want to, do you think that it's going to meet at infinity with this x-axis? Yeah, that is the expectation. This is also, it has to be like this. Now this graph, this x value can come closer and closer and closer and closer and closer and closer, but it will never ever come to x equal 1. Because when you put x equal 1, this is become 1 over 1 minus 1, 1 minus 1, 1 over 0 become infinity. Right? X equal 1, there is no answer for x equal 1. Y equal 1 minus x minus 1, it means 1 over 1 minus 1 It means 1 over 0. There is no answer for x equal 1. So only the answer is when this one getting the graph will touch at the infinity. So in general, we don't take x equal 1 is the answer for this. Basically, for this graph, we can't find a value for x equal 1. So because of that, this is become asymptotic. So now this is which asymptotic? This is horizontal asymptotic. Sorry, vertical asymptotic. Same way, this is become this is vertical asymptotic, and this is horizontal asymptotic. Asymptotes. Now my next question is y equal 2x minus 1. What is the asymptotic asymptote? So this is a reciprocal function. What is the asymptote? The asymptote for this one is x equal half. You can see that when you put 2 times half a times 1, this is 1 over 1 minus 1, it makes 0. Then this is become infinity. Because of that, you have to write x is not equal to half. So you can easily find this one. What is the asymptotic? You want to take this expression 2x minus 1 equal to 0, then x equal half. Another one, y equal ax plus b. What is the asymptotic for this one? So simple way is you make ax plus b equal 0, x equal minus b over a. Then you have this is x can't be minus b over a. This is when you write this function. Another asymptote y equal another graph, reciprocal graph. So what is the asymptotic? X square equal 0, then x equal 0. So you have to write x can't be 0 because it is the asymptotic. So x equal 0 is the asymptotic. Now, what is reciprocal? We didn't talk about reciprocal. Reciprocal of 2 is half. Reciprocal of 3 is 1 over 3. That's how we write 1 over. Reciprocal of x is 1 over x. Also, you can write in other way. This is the area you may not know. That's fine. Let's forget about. Half is the, so reciprocal of 2 is half. Or you can write differently. Half is the multiplicative inverse of 2. 1/3 is the multiplicative inverse of 3. 1 over x is the multiplicative inverse of x. In other way, 2 times half make 1, because this is the identity under 1 is the identity under multiplication, and 3 times 1 over 3 is 1. Likewise, x times 1 over x is 1. So multiplication, so 1 over x is the multiplicative inverse of x, or reciprocal of x. 1/3 is the multiplicative inverse of 3, or reciprocal of 3. Half is the multiplicative inverse of 2, or reciprocal of, or you can tell instead of that, reciprocal of 2. Finally, it is like in terms of day-to-day life, two variable moving to the product of two variable always gives 1. This is in day-to-day life, not mathematically. Now what is the y value? X times y equal 1. What is y? What is y? To make 1, this y has to be, what is y? To make 1, there is x, then I have to write 1 over x to cancel out. It means y equal 1 over x. To get an idea, I believe you can understand now 2 times half is 1. You can understand this, so that's fine. If you want to get an idea, it will time consuming. You have to read about the characteristics of number systems. Number systems. Then according to the number systems, we can categorize, they will categorize group, ring, field. So even if you look at the what is group, or what is ring, or what is field, you will see that this about these identities. So this is under number systems, the characteristics of number systems. Number systems, you can see real numbers, natural numbers, complex numbers, I think complex, and matrices. Likewise, you can see.